Imagine having your own secret underground bunker, far away from everything, entirely yours and yours alone. In this video, you'll see the journey of building the perfect bunker. We'll dig with our own hands, reinforce the walls, and design the place to be the strongest and most comfortable space you can imagine. Step by step, we'll turn the idea into reality and live the experience in full detail. Don't forget to like the video, subscribe to the channel, and let's get started. This bunker provides safety against many things: solar flares, nuclear fallout, or even hiding from zombies. Jerry had dreamed of this since he was a child. At first, he considered using a regular shipping container, but he rejected the idea. Instead, he chose a design made of a massive pipe, typically used for stormwater drainage. Its interior is spiral-shaped with a diameter of 12 feet, absolutely huge. He chose this for several reasons, the first being that it can last up to 100 years without any problems. And of course, because of its enormous size, it offers tremendous space. These pipes are transported using two massive trucks, along with a tractor and a crane. A single 20-foot pipe weighs about 4,000 pounds, nearly 2 tons. The crane carries the entire pipe as if it were strapped to it. These two pieces cost about $31,959 in 2023. The pipes are designed to withstand burial at depths of up to 100 meters, since they're already used worldwide for storm drainage. Their structure and engineering are well known among builders and engineers, and they've been tested and certified. The bunker was designed to accommodate 6 people, and Jerry needed to start work quickly before the snow arrived, especially since his neighbors were suspicious that he was up to something unusual. As I mentioned, these pipes can be buried as deep as 100 meters underground, but Jerry decided to place them only 6 feet deep. He explained that he did this to take advantage of the natural thermal insulation of the Earth, which would also help keep the space warm during winter. Especially since winters there are no joke, literally brutal. The idea is that this pipe, when above ground, isn't as strong as it is when buried underground, but once it's placed beneath the soil, a natural layer of clay adds tremendous strength, allowing it to handle massive loads without any issues. At this stage, we needed to study the exact spot where the pipe would be placed underground. Since the pipe needed to be lowered 6 feet deep and its diameter was 12 feet, we had to dig down 18 feet. Now, the pipe's edges had to be reinforced so they could attach lifting points for hoisting. Every joint had to be welded with extreme precision to prevent any problems. They built a circular frame matching the pipe's dimensions, and every section was carefully welded together. Thankfully, the welding was completed successfully, though there were some minor measurement mistakes at first, which they corrected. In the end, the structure was welded properly and securely. Then the heavy work began. The excavator arrived and started digging in the yard to prepare for placing the first pipe. The initial layer of grass and soil was removed piece by piece. 2 excavators worked together, one digging and the other lifting the dirt and moving it away. But instead of just dumping the soil anywhere, they placed it in a designated disposal site, since it would later be reused. Of course, before digging, they made sure there were no gas or water lines beneath the area, because you can imagine the level of disaster if digging started and those were there. A laser rod was used to ensure every measurement was precise to the millimeter. After confirming the dimensions, the excavator resumed its work. Each time, the same laser rod was used to double-check accuracy. In the end, the last layer had to be dug manually, since the excavator couldn't reach that depth, and if it went down too far, it would never come back up, which would create serious problems. To avoid that, they finished the bottom by hand. Then the crane arrived and began lifting one of the massive pipes. It was raised to a terrifyingly high level. Just that crane rental alone cost $1,800 for the entire day. With the first pipe now in place, it was time to bring in the second one. After it was lowered, both pipes were finally underground. The next step was to secure them tightly together. They began adjusting the height, since they weren't perfectly aligned, and because the bolts needed to match up. At last, the first bolt was installed. These bolts are extremely strong, designed to hold the pipes firmly together. Of course, once the soil is packed around them, the pressure will naturally keep them in place, but the bolts add extra security and stability. Now that the pipes were joined, the team had to build an elevator system for entering and exiting the bunker. Steel plates were cut with a grinder and carefully measured. Before welding, every piece was checked to ensure the dimensions were exact and the surfaces smooth enough to fuse properly. After welding and assembling multiple sections of steel, the result was a heavy iron cage. The cage itself weighed more than the vehicle they were using, which meant that once it touched the ground, the car was lifted slightly off the ground as well. Next, large steel beams were welded together to create the elevator shaft's outer frame. This work was exhausting, especially since they were handling massive weights underground. The temperature beneath the surface was a bit high, though still tolerable for living, but not for extended periods of time. For that reason, they planned 2 ventilation systems, one for biological hazards and another for heating and cooling. The problem with heating and cooling, however, was its massive power consumption, around 1,500 watts. That's why Jerry chose this particular bed, a smart bed that can literally heat or cool itself. Even more, it can be split in half so that one side stays warm while the other stays cool. It also tracks your sleep, heart rate, eye movement, and much more. The only issue is that it requires Wi-Fi to operate, and if the world truly ends, the bed would simply stop working. As for the cranes, their advantage isn't just in excavation. They can also be used to lift and move just about anything. They used the crane to lift our unusual elevator, and it handled the task with ease. Finally, everything came together. The elevator was set upright. Metal panels were then attached to the elevator's frame. These panels alone cost $6,149. The crane itself was truly impressive, able to lift all that weight while maneuvering through tight spaces between houses and trees. It was worth every dollar spent on renting it. After that, the elevator was lowered into the bunker. To secure it, extra steel reinforcements had been welded to its base so that they would anchor into the ground beneath. Once the elevator was lowered into place, it stabilized itself within the soil. The pipe structure and the elevator frame were connected with heavy-duty bolts, and this was all solid steel and metal, not just wood. At this point, the pipes needed to be coated with a water-resistant layer, since rainwater could eventually damage them if left unprotected. Unfortunately, during the welding process, a fire broke out and damaged some parts, but those were repairable. Securing the entrance and exit of the bunker was also critical, because if someone went inside and the entry collapsed, it would turn into a grave, not a shelter. Since there was only one elevator shaft, they decided to add a second one as a backup, in case anything went wrong. After cutting a new opening on the other side of the bunker, it was time to smooth and clean the interior of the pipe. The floor inside had to be leveled so that both people and equipment could move around easily. Welding had sometimes left uneven spots along the pipe, so they had to ensure everything was properly fixed before covering it back up with soil, otherwise leaks could occur. It was also extremely difficult to walk on the spiral-shaped inner walls of the pipe, which were slippery, so installing a full, solid floor was absolutely necessary. Once the flooring was installed, there was more space to move around easily. To connect the entry shaft to the base, they used something called a magnetic drill. This tool relies on an electromagnet to cling to the bunker's steel wall while drilling large openings in the elevator or pipe structure, allowing bolts to be inserted. Straps and concrete blocks were also used around the bunker to prevent it from shifting or lifting once gravel and soil were packed back in. On top of that, a waterproof adhesive was applied to ensure no problems would occur once the soil was added. They then mixed specialized materials together to create a coating resistant to rust and corrosion, ensuring that the pipe would last for a very long time. Every part of the pipe was coated, including the elevator itself. Afterward, a circularly cut metal piece was placed over the pipe junction to secure the two sections firmly together. If you thought this was just a matter of dumping dirt over the bunker, you'd be mistaken. The reality is far more complex. The original soil had been naturally compacted over millions of years, but once it was disturbed, it became very loose, especially with rainwater soaking into it. To handle this, a truck called a gravel spreader was brought in, which poured soil from a height of 60 feet. It had to be spread in a precise way, since the loosened earth couldn't support weight properly on its own. Small, dense gravel was used to help compact the soil as it compressed under its own weight the moment it was released from the truck. Workers also went underground, spreading gravel beneath the bunker to eliminate any air gaps. If empty spaces were left, the pipe could shift or vibrate freely underground, something they absolutely wanted to avoid. They even used machinery to press and compact the gravel tightly under the pipe. Additionally, the green straps you see were used to stabilize the pipe further. These straps were tied into the concrete foundation beneath the soil from the very beginning, giving the structure even greater stability. They also sprayed the soil with water to make it heavier, essentially trying to replicate in a few days the kind of pressure that would normally take millions of years to form. At the same time, they adjusted the soil so that insects and organisms that once lived there could return to their natural environment. The backup exit shaft, the secondary elevator, was also installed and secured inside the bunker. They then added a special component, similar to the anode rod found in water heaters, which normally needs replacing every 5 years. This was a 15-pound piece of zinc designed to be attached to the bunker as a sacrificial layer of protection. Instead of the bunker corroding over time, the zinc would gradually wear away, providing an extra level of safety. The process of refilling the pit actually took longer than digging it out. After each layer of soil was added, the same compaction procedures had to be repeated from the beginning to increase ground pressure. Eventually, the pipe began to disappear underground, and once the final layer of clay was returned, it was completely buried. When the original topsoil was restored, grass was replanted to make the surface look exactly as it had before. Now it was time to head inside and see what they could build underground. The temporary hatch door was removed, and a provisional ladder was installed to climb down. The bunker was eerie, naturally so, since it was buried 6 feet below the surface. To make it usable, they first installed a metal subfloor to stand on. Because breathing underground was difficult, 2 fans were set up to extract air and welding fumes. Next, metal beams were fastened along the length of the interior walls, and a wooden floor was laid over them. This transformed the round pipe into a flat, usable space. Looking beneath the wooden floor showed the raw pipe structure still intact. Up to this point, the project had taken 2.5 months to build and had already cost around $98,000, a massive investment. Well, Jerry is quite wealthy, more than a little, so for him the cost wasn't a problem. In his view, for what he was building, it was worth every penny. Now it was time to build the elevator. Instead of installing a traditional lift, which would have been extremely expensive, they repurposed a second-hand scissor lift. The first step was repairing the vehicle and removing unnecessary parts that served no purpose in the bunker. This reduced weight and also freed up more space inside. After a lot of work, the mobile elevator was finally completed, and once installed underground, it would remain there permanently. Of course, to create a solid foundation for the elevator, a large amount of reinforced concrete had to be poured. While the concrete was still wet, 4 steel anchors were embedded into the base. These would serve as the attachment points for the elevator. After a great deal of effort, the elevator was installed with high precision, fitting perfectly onto the pre-placed bolts in the concrete. A ladder was also positioned alongside the elevator as a backup, in case it ever malfunctioned. The elevator was especially important because Jerry's wife used a wheelchair, and this ensured she could access the bunker without difficulty. To begin dividing and organizing the interior, Metal panels were fitted around the pipe circumference. These panels reinforced the structure and also served as a framework for the rooms that would later be built. The elevator played a crucial role in this stage, since it was the only way to lower heavy materials and equipment underground. Next, they began working on the electrical system, running wiring through the lower levels and carefully setting up the foundation for the power grid. After a long stretch of time and effort, the electrical area was completed, and the rooms were partitioned as well. The next step was to create solar panels that would generate renewable energy for the bunker. For this, they used detailed 3D designs as their blueprint. We then went to a machine that cut and prepared the materials needed to build the solar panels. The steel that had been removed earlier to create the backup entrance would now be reused for constructing the frames. We also moved on to finishing the secondary entrance, making sure it was well hidden. In short, the idea was to disguise it so that no one could recognize it as an entry or exit point. Finally, a large rock was placed over it, serving both as decoration and camouflage so that it blended naturally with the surroundings and kept the bunker's location secret. Next, we installed the solar panels above the main elevator shaft. Metal supports were brought in and wheels were attached to make opening and closing the panels easier. The panels were mounted securely, with bolts fastening them tightly. To improve the look, a frame was built around the entire system, ensuring it didn't appear out of place. The wiring was connected afterward, though it needed some adjustments since it couldn't be left exposed. Once it was organized and hidden properly, everything was in place. At this stage, the system was generating about 200 watts of solar energy. The 2 panels alone were enough to cover all the bunker's energy needs. And just like that, the bunker was complete. Some additional finishing touches were done later, but unfortunately, they weren't filmed. Still, the entire process is now clear to you. So, what do you think about this challenge? If you had an unlimited budget, would you attempt something like this yourself, or maybe even take on a crazier project? That was today's video. Thanks for watching, and goodbye.